This week is week 13. In modules 13 and 14, we will go over chapter 8. So this week, we will go over the first half in chapter 8. We will talk about advanced procedures. On Tuesday, we will talk about the stack frame. So we talk about the memory stack, how we will push the value into the memory stack. So this week, according to the procedure, we will see how can we use the memory stack to save the parameter operand. And if you have any local variable in your procedure, we also can access that from the stack frame. On Thursday, we will give you the example for the recursive function. So through the recursive code, you will see the return address occupied in the stack memory. So then next week, we will talk about the second half for the chapter 8. So we will focus on how to create multiple program projects in assembling language. You will write your own, kind of like the header file you have. So let's see here what is the stack frame. So if you remember in chapter 5, when we talk about procedure, we're only using the code instruction to call the procedure name. So that we first introduce how to implement procedure in assembly language. So in this chapter, we say advanced procedure. So that means we will pass in the parameter we will using the local variable in our procedure. So we will see what that will happen in the memory stack. So we will focus on the parameter we are passing, the local variable we are using in the procedure. So after you understand the concept, then we will talk about other directives to easier to implement our procedure. So the first thing I want you to see this example. So actually this one is from chapter 5. So in chapter 5, if you remember, we start using the Irvine32 library. We have a procedure called dump memory. After you call the dump memory, you can display the content for your array. So before you call the dump memory, if you have any value you want to pass, from chapter 5, we using the regist to carry those values we need. So for example, you need to have your address for your array in ESI. You need to have your how many elements in the array in the ECX. So then the EBX will know each element, how many bytes I need to display that element. So we'll pass in the type of array to the EBX. Then you call dump memory, so you can display the content from the array. So by using all the registers for the information you need, so sometimes we need to do the push add and push pop in our procedure implementation. So we can make sure all the register value after and before you call the procedure, they won't change. So that's the concept from earlier when we talk about procedure, how should we implement that? But now you can understand your ECX, EBX, and ESI, those values we need is kind of like in C++ or Java, we have a function, we need to pass in the parameter. So the first way you can do is you have those passing parameters saved in the register. So here, actually in chapter 8, when we talk about the advanced procedure, we were using different way to pass in our parameter. Remember, we talked about we have memory stack. So anytime if you want to save your information, you can push to the memory stack. Then you need to pop out from the memory stack. So the concept how to using the passing parameter and the local variable for the advanced procedure, we will do is we will use those stack memory to save the value we need. So on the other hand, before you call dump memory, you can just push the value you need order one by one into the memory stack. So from the procedure, we can access those memory stack value. So then we can get the value to do the corresponding work. Of course, since you push those parameters into the stack, right? So after you finish your procedure, you will pop back those values. So by this idea, we will see how should we save those parameter value or local variable we need from the procedure into our memory stack. So here actually is how we will do. So here we say the stack frame. That's basically just like the stack memory. You will using those area of the stack for passing argument. So this one with passing argument, that's mean the parameter variable you want to passing by. So then remember when we call the procedure, we will have the procedure return address pushed to the stack. So addition to that, we also have the local variable. If you have any save regist, you can use the stack memory to save that. So in order to have the passing parameter and the local variable you want to use in the procedure, so here is a sequential step we will use. So I will introduce the step first, then I will explain what that happened. So the first thing, before you call your subroutine, please pass in the argument. If you have any passing argument, push them to the stack. Just like earlier we showed you. You push the address for the array. You push the length of the array. You push the type of the array before you call dump memory. So since you call the procedure, right? Remember last in chapter 5 we say whenever you call the procedure, automatically they will have the return address pushed into the stack. So that we already know in chapter 5, but we have more now. So the number 3, actually you will have the subroutine start execute. Then we will introduce another regist we call EBP. So that's the base pointer for each procedure you will work. So this base pointer have an address. So this value will push to the stack. So then the base pointer we will set equal to the stack pointer. So the base pointer kind of is a value we will save to see how we will restore the stack after the procedure finish. So then after you set this EBP equal to the current ESP, from this point you will see, right, EBP will act as a base reference for the call of all the subroutine parameters. So after you have this EBP, right, if we want to access different passing argument, we're just using the EBP to plus the value. So then if you have any local variable, so then we will have the ESP decrement to reserve the space for the variable on the stack. So then, of course, if you have any regist you want to save, they just push to the stack. So then we will see how they will work. It sounds, don't know what they do, right? Because the reason is you didn't see how the memory stack work. So that's why after you have those procedure 1 to 6, I just want you to refer to this step. So we see this example. This example we call add to example. That's a very simple example. You always see you can do that in C++. But we will see how can we do that in assembly language. For example, in C++, you see you have a two integer x and y. You want to add them together, then you return the sum. So that's you will do, right? Your return type is int. Your parameter is x and y. So you just return x plus y. But one thing is here we show you, right? So I will write an add to procedure in assembly language. So how should I code this procedure? Just like earlier we said, since we have two parameters, right? So we just say, for example, x equal to 6, y equal to 5. So we're using the constant number because remember, when you have your function, the passing parameter also can be the constant number. We just assume that now the parameter we want to use is constant number. So you have 6 and 5, you just push to the stack, then you call the add to procedure. So that's the first step. We show you how to code this function, right? But how should I implement add to procedure? So actually add to procedure look like this. Your add to procedure, you have the directive and end and return. Okay, so now let's see what happened. So I just say, for example, this one is the memory stack. We see what happened. So this one is our add to procedure, right? So remember before that, we push 6 and push 5, then we call add to. So that's why here you will see the stack memory. Here we have 5. We'll have 6, we push, then we have 5. So then we call this add to procedure. So that's why your return address will be pushed to the stack. So then the second step, we say now you're using your push EBP, right? So that's why here we push the EBP value. Okay, so then we make the EBP equal to ESP. So you need to be careful which one is ESP. So before I push EBP, ESP actually is pointing to here, right? Because remember your ESP is the stack pointer. So we just say, for example, this one is our stack memory. So then we show you earlier, right? So we say here, you have your, before you call your procedure add to, you need to push 6, push 5. So then after you call add to, you have return address here. So then where's the ESP? Remember, ESP always point to the last value you push into the stack. So now here we push the EBP. Okay, so after you push the EBP, okay, so now you push EBP, right? You push EBP, that's make ESP come here. So now here, this EBP actually is the old EBP. So then here, your ESP will have the value saved into your new EBP. Okay, why we need to have EBP? Because earlier we showed you, this EBP value actually will be the reference to refer to the memory on the parameter list we have. So since here is the new ESP location, right? So you see add 4 is referred to this return address. So at 8, you will access 5. So at 12, you will access the 6. So they will look like this. Remember, after we push EBP, we make the EBP equal to the ESP. So that's the current location. From this current location, that's now is the new EBP. Okay, so here, the purple I just showed you, that's the new EBP value. That's equal to the ESP. So this EBP value actually is the base pointer. So using that, we can access our value for our passing parameter. So that's why here, the first one we push, they are referred by EBP plus 12. So then the second one we will access, that's EBP plus 8. So now, can you access the passing parameter you have? Right, so that's why we move the EBP plus 12, the 6 equal to EAX. So then we add the next one, EBP plus 8 equal to the EAX. So of course, then your sum will be the in EAX. But don't forget that since you push EBP at the beginning, so after we finish, we just pop the EBP back. So after you pop EBP back, this EBP will restore the old value, right? So then you see your return address, you finish that. So then that's our stack frame. So I will show you more in detail in the next video clip. So here we only have 15 minutes.